Okay, so this is problem 5b, and the question is just asking us to simplify this expression. 5a didn't give so much trouble as 5b, so I'm only going to do 5b. So there are two methods of doing this. I'm going to do it both ways. I hope I don't confuse you more. So the first method I'm going to use is I'm not going to clear the fractions. I'm going to deal with the fraction in the top and the bottom. The basic idea is that if you have a fraction divided by a fraction, then this is equivalent to having the first fraction multiplied by the reciprocal of the other one. So I don't have it set up like that. So I want to rewrite the numerator so it has this form, and then the denominator so it has this form. Once I have that, then I can just multiply by this one flipped. So how do I write the numerator as one single fraction? Well, in the numerator, I need to combine them to have a common denominator, which would be x, right? So how do I write this first x with the denominator x? Well, that's like an x over a 1. I'll draw a little 1 there. So I multiply top and bottom by x, and this becomes x squared. So x squared over x is the same as x over 1. And the second term, this one, is already over x, so just minus 1, correct? Now, in the denominator, it's the same thing, and my common denominator is going to be x. So how did I get this 1 over 1 as a denominator x? Well, I'm going to multiply top and bottom of that fraction by x. So it's going to be x plus 1 over x. Okay, now I have it in this form where this is my numerator, my fraction on the top. This is my denominator, fraction on the bottom. So I can now use this rule that I wrote down here. So this would give me x squared minus 1 over x times the reciprocal denominator, so I'll have an x on the top, and x plus 1 on the bottom. So this looks good so far. The problem is that we're not done yet. Of course, the x's cancel. I hope you see that. So if you're multiplying, this is a factor, and this is a factor, so they cancel. That's 1. X over x is a 1, so you can appear. But there's more to it. This numerator part can be factored. This part, I can factor it like x plus 1, x minus 1. This denominator still has an x plus 1 because this guy is still here. So now I can keep going, and what's going to happen is that these x plus 1s now cancel. It's a whole factor. So my final answer is x minus 1. So that's the final answer to solve this one. So the way I did it here was using this denominator, this rule that you would fit by the denominator. This is my favorite, but it sometimes is not the favorite of students or other instructors. Let me see if I can erase something around here. I can't erase, so I'm having trouble erasing this. So I'm going to do it again in the other in a new slide. So let me go over here, and so I'm going to write down the problem here. So we had the problem was x minus 1 over x divided by 1 plus 1 over x. So we're going to treat this one as a different method, and some students like this one most because it feels like you're dealing with less with the fractions, and you don't have to do the step where you have to multiply it by the reciprocal. It's basically the same principle. What you're going to do is to deal with the common denominator from top and bottom. In this case, the numerators, the fractions in the numerator, so these fractions have a denominator of x, this guy has a 1, and these guys also have a denominator, the lowest common denominator, which is an x, right? This one has a 1. So I'm going to use that so I can, if I can erase these guys, okay. I can use that to multiply top and bottom by x. I'm going to multiply the top by an x and the denominator by an x. I can do that because x over x, I'm multiplying a fraction by this, which is just a 1, right? So that's what I'm doing. Okay, so if I do that, and the point of doing this is that the numerator simplifies a lot, right? If I multiply x times x, distribute that, you get x squared. X times the negative 1 over x just gives you a negative 1 because the x part becomes x over x is just a 1. Then in the denominator, I distribute this x, so I get x, and I get plus 1. So we arrive very quickly to this step, right? We don't have to deal with this. This is like the final part of our other method. I still have to factor the numerator, and you get the same answer as before. So either of these methods work, and either of these methods are valid, and it gets you to the same answer. Okay.